Last time through, we looked at factoring trinomials that did not have a leading coefficient greater than 1. It was just x squared plus something times x plus a number. The trinomials are not always going to look like that. Sometimes there'll be a coefficient in front of the x squared term, and we want to look at what's our strategy for factoring those types of trinomials. Well, let's remind ourselves once again what happens when we multiply two binomials together. So if I go 3x minus 4 times 2x minus 5, I'm going to start by taking the 3x times the 2x minus 5, and then come back with the negative 4 times 2x minus 5. So 3x times 2x, 6x squared. 3x times negative 5, it's negative 15x. Then the negative 4 times the 2x, negative 8x. Negative 4 times negative 5, positive 20. So we do the distributive property twice, and we get 4 terms, 6x squared minus 15x minus 8x plus 20. I'm going to combine my like terms, negative 15 and negative 8. That's negative 23x. 6x squared minus 23x plus 20. So as we reminded ourselves when we looked at x squared plus bx plus c, what would happen then if we were asked to factor 6x squared minus 23x plus 20? So previously we'd taken a look at this and we said, okay, I need two factors of 20 that are both negative and that they add up to 23. Well, my factors of 20, let's see what I have. 1 times 20, 2 times 10, 4 times 5, and that's it. Well, 1 and 20, those only add up to 21. I'm not going to have any pair here that's going to add up to 23. I don't know what to do. And then I look and I see that there's a multiplier in front of the x squared. So I no longer just have x and x. I'm going to have factors of 6 that are part of this as well. And I think, oh, I'm not sure how I'm going to account for that. And there's a handful of methods for doing this. The one we're going to use, we're going to take that 6 and we're going to multiply times the 20. So I'm going to go with 120. Pretty big number, but we can break this down. 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 8 and 15, 10 and 12. So now we want to look for a pair of numbers that multiply together to make 120 that add up to 23. And I look down my list and I see, 8 and 15. Here's how we're going to approach this. We're going to take this negative 23x and we're going to rewrite it as 8x, negative 8x minus 15x. And then bring in my x squared term and my constant term. So now I've got this group of 4, and I'm still trying to break this down into two binomial factors. And it looks like I'm going the opposite direction. I started with 3 terms, now I've got 4. How am I going to break this down to binomials? We're going to take this 4-term polynomial and split it in 2. And we take the GCF of each of these pairs of terms. So for instance, 6x squared minus 8x. Well, I can see that 2 goes into 6 and 8. X goes into x squared and x. I've got a 2x. Well, what remains? 2 times some number gives me 6. That's 3. X times something gave me x squared. So 2x times 3x is 6x squared. When I factor the 2x out of 8x, that leaves me with 4. I close my parentheses. Now I'm going to do the same thing to this grouping here. So I see I have negative 15x and positive 20. So I know no variable is going to be part of this because 20 doesn't have a variable piece to give. The biggest number that goes into both of these is 5. And in fact, I'm going to factor out a negative 5. So let's see what remains. 5 times 3 gives 15, so 3x. Negative 5 times negative 4 is positive 20. So 2x times 3x minus 4 minus 5 times 3x minus 4. If we do this right, these two factors in parentheses will be the same. Sometimes that helps in figuring out what GCF to factor out of this back end. So now I've got a common factor of 3x minus 4 I'm going to bring that out. My two GCFs that I factored out earlier, 2x minus 5, is going to be my other factor. So factoring a trinomial that has a leading coefficient greater than 1 is going to involve this method. I'm going to split that middle term into 2, use a method called factoring by grouping to split those 4 terms down into 2 binomials, 2x minus 5, 3x minus 4. So let's look at a couple for practice. 3x squared minus 10x plus 8. The 3 times the 8 makes 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are my factors. They're both going to be negative. This is positive, so same sign. And this tells me they're both negative. I need 2 factors of 24 that add up to 10. 4 and 6 looks like it should do it. So 3x squared minus 4x minus 6x plus 8. My GCF here. 3 and 4 don't have a common factor. All I can factor out there is x. So 3x minus 4. Here, we've got negative 6 and positive 8. I can factor out a negative 2. And that will leave me with 3x minus 4. Again, if we've done this right, the remaining polynomial factor is going to be the same. So x minus 2, the 2 GCFs that I factored out, and then my common factor here, 3x minus 4. Go ahead and pause the video, give number 2 a try, then you can come back and check your work. So 6 times 15, that's 90. My factors of 90, 1 and 90, 2 and 45, 3 and 30. 4 doesn't go in, but 5 does, 18 times. 6 times 15, 9 times 10. So this time it's negative. So I have 2 factors that multiply together to make 90, and when I subtract I get 1. So they're one number apart, and that's 9 and 10. So let's write this. 6x squared, it's positive x, so the 10 is going to get the positive sign. 10x minus 9x minus 15. GCF of 6x squared and 10x. That's going to be 2x. 2 times 3 gives me 6, so 3x. 2 times 5 gives me 10, so plus 5. Now I can see that both of these terms are negative, so I know my GCF is going to be negative when I factor it out because I want this remaining, 3x plus 5. Looks like I should take out a negative 3. So 2x minus 3, 3x plus 5. Let's take a look at 3 and 4. Now, an important strategy whenever we're asked to factor, regardless of the type of polynomial, is first to check to see if we can factor out a greatest common factor. I want to see if all 3 terms can be divided by the same thing, and I can remove that factor first. And in both 3 and 4, that's going to be our situation. 6, 27, and 15 all divide by 3. So 6 divided by 3 makes 2. 27 divided by 3 is 9. 15 divided by 3 is 5. So 3 times 2x squared plus 9x minus 5. Now I can factor this in the same way we've done before. I need factors of 10. 1 and 10, 2 and 5. 1 and 10 is going to work here because I need positive 9x. Very important to bring the 3 along all the way on down. So here I can see that my remaining factor is going to be x minus 5. I'm going to match up here as well. So 2x squared, 10x. I can take a 2x out there. oops, that's minus 5, excuse me, 2x, and I'm left with x plus 5. Here, I want this to be x plus 5, so my factor is going to be negative 1. Negative 1 times negative x is going to give me positive x. Negative 1 times negative 5 is going to be positive 5. X plus 5. So again, not losing the 3. 2x minus 1, x plus 5. Factoring here, 8, 28, and 120. Well, 4 goes into 8, 4 goes into 28, 4 goes into 120. 8 doesn't go into 28, so I can't take the full 8 out. So let's factor out that 4. 2x squared plus 7x minus 30. So I need factors of 60. 2 times 30. 1 and 60. 2 and 30. 3 and 20. 4 and 15. 5 and 12. 6 and 10. These need to be 7 units apart. So 5 and 12 is going to do it, and 12 is bigger, so 12 gets the positive. 12x minus 5x. I've rewritten 7x as 12x minus 5x. Here we go with factoring by grouping. I can take a 2x out here. Leaves me with x plus 6. I can take a negative 5 out here. Leaves me with x plus 6. And don't forget, the whole thing is multiplied by 4. So 2x minus 5 is one of my factors. The repeating factor, x plus 6, is the other. So completely factored looks like this. Some new vocabulary. Zeros of a function. Last time we looked at the zero product property. If I multiply two factors together, my product is 0. It tells me at least one of those factors is 0. So when we refer to zeros of a function, we're talking about the x values that makes the function's value equal to 0. So the functions are the same as the x-intercepts of the graph. So to find the zeros, we use the zero product property. Let's look at an example. We want to set this equal to 0. 4x squared minus 17x minus 15 equals 0. Now, we need to factor this. 4 times 15, I need factors of 60. We just did this. Should be pretty quick to run down the line, right? 4 times 15, 5 times 12, 6 times 10. Now I need two factors that are 17 units apart. That's 3 and 20. So 4x squared minus 20x plus 3x minus 15 equals 0. Fourth or fifth example we've done, so I'm going to move a little bit quicker. I can see that I can take a 4x here, x minus 5. 3 and negative 15, I can take a negative 3 out and have x minus 5. See this? Positive 3. And that's set equal to 0. So 4x plus 3 times x minus 5 equals 0. Now, we go ahead on down the line and solve this. 4x plus 3 equals 0. Or x minus 5 equals 0. Minus 3 minus 3. So x equals negative 3/4, or x equals 5. So these are the zeros of the function.